So this piece of this unit is about looking at what basically goes on with exponential functions a little more in depth than we've done in the past, just so that we understand the idea of what they're doing and how they go onto a graph, which we'll look at in the next section after we finish going through and just kind of looking at some different things about basically taking data and turning it into an exponential function. Okay, so a couple of things about exponentials. They have a horizontal asymptote. Every exponential function has a horizontal asymptote someplace. They do not have a vertical asymptote, but they have a horizontal asymptote. Remember, an asymptote was a line that they don't cross, so they just get increasingly closer to. So if I had a graph, usually it was like a dotted line across there. A horizontal asymptote means that it goes like that. All right, and it just goes along that line, gets a little bit closer to it each time, but never actually touches it and never crosses it. So they have a horizontal asymptote. On the end of the graph, or one end of the graph tends to infinity or negative infinity, and the other end levels out at a horizontal asymptote. And that means that the graph goes up, all right, forever, or it goes down forever if it happens to be flipped over. So that happens for every exponential function. It might be a little steeper, or a little flattened out, depending on what it looks like, but they all have that basic shape to them. All right, the basic exponential function looks like that. All right, it has two numbers, all right, an A and a B. All right, the B incorporates the growth factor. The A is just typically where it starts out at. All right, so the A value is the y-intercept. That's what happens at 0, which is why it's what it starts out at. And the B number is the growth factor. All right, so this is where we're going to take our look at in this section right here. There are growth functions and there are decay functions. All right, so if that B value is greater than 1, it's going to be growing and getting bigger as it moves to the right. All right, if the B value is between 0 and 1, then the graph is going to decay or get smaller as it goes to the right-hand side. All right, and the big thing is B can't be negative because then it wouldn't make a function. It would make a thing that kind of jumped around all over the place because negative numbers don't behave well when they have an exponent on them that's constantly changing. All right, so that's what we're looking at there. So growth and decay are what we're going to want to talk about first. All right. Transformed thing here. The horizontal asymptote is going to be the number at the end there. All right, so we've done shifts before. The number at the end, that's up and down. Whatever number that is going to be the horizontal asymptote because it's normally y equals 0 or the x-axis. So then any kind of shift up or down will change it to that. So if it was -3, it would be y equals -3. All right, and then the x-intercept is the a value plus whatever, the y-intercept is the a value plus whatever the k is. All right, in a standard thing, the a value is 1, they all cross at 1, and then we start doing different things with them. So as we go down through here, we're basically just kind of looking at some very, very simple, basic things with these exponential functions. We'll model them, meaning we'll take data and create exponentials from them in the next two sections. And then after that, we'll start looking at graphing, and then we'll finish the unit up with actually solving these equations, which is what we really want to be able to do with them.